Hello everyone, welcome back. My name is Prabhash Kumar and I'm teaching you engineering mathematics. So we have started a new course on engineering mathematics and we have already completed 2 lessons, and this is the 3rd lesson of engineering mathematics, which is binomial theorem. Okay, so let's start. See, we have already completed powers and roots, we have already completed logarithms as well. Now we are in the 3rd step, that is binomial theorem. After completing this binomial theorem, we will be entering into sequences. Okay, so let's see binomial theorem. Now, what is the basic definition for this binomial theorem? So what does it do? Binomial theorem is nothing but it's a theorem which describes the algebraic expansion of the powers of a binomial. Okay, what do you mean by binomial? Whenever you see any word, just letter by means what? 2. Okay, so this is x plus y whole to the power of n. So this is a polynomial. What kind of a polynomial? Binomial. Okay, if it is a 3, so that will be considered as a trinomial. If it is a 4, then that will be considered as a quadrinomial. Okay, now here we'll be focusing only on binomial theorem. Why? Because we have only 2 terms of it. Okay, so x plus y whole to the power of n. What is the significance of it and what does it do? So binomial theorem states that it is possible to expand the polynomial, say x plus y whole to the power of n. So let's say we have an expression x plus y whole to the power of n, and this could be expanded into the sum involving the terms of the form. Okay, so we'll be seeing an expression in which these type of term will be coming into picture. What is a? A is nothing but the coefficient, and this coefficient will be always an integer. Okay, now this is here x, and this is x, and let's say it has a power b, and this is y, and so y is having some power c. Okay, so where b and c are the non-negative integers. What is b plus c? B plus c, if you add this will give you n. So make sure that whatever the power of x is, whatever the power of y is, so the summation of all these 2 powers should give you the power of this polynomial. Alright, coming to factorial. See, for studying this binomial theorem, we should have a very good command on this factorial. Okay, so what is this factorial? Factorial of a positive integer n is defined as the product of all positive integers less than or equal to n. See here, I have underlined this very specifically, positive integers n. So now some of you might be thinking, that means if I have underlined this, that means we could find the factorial of only positive integers. Is that so? No, it is not that so. Okay, so we'll see that we can find the factorial of negative numbers as well, fractions as well, but for the time being, this is the generic definition, in a sense that, see, we have written that the factorial of an integer, whenever we talk about a factorial of an integer, so that will be considered as the product of all positive integers less than or equal to n. So here the factorial of a positive integer n then we are talking about. So it means that it is nothing but the product of all positive integers, which should be less than or equal to n. Let's say an example. So whenever we talk about, say, let's say 5 factorial. So 5 factorial means 5 into 4 into 3 into 2 into 1. So keep on subtracting 1 unit. So 5 into 4 into 3 into 2 into 1. Okay, so for finding 7 factorial, keep on subtracting 1 unit. 7 into 6 into 5 into 4 into 3 into 2 into 1. 1 factorial 1. Now you'll be asking, sir, how this is 0 factorial becoming 1? How this is possible, sir? So you are subtracting 1 unit from each. Then how this is possible? So let's see. Now you'll be saying, sir, prove how this 0 factorial is becoming 1. So dear students, please look at the pattern carefully. So 5 factorial could be written as 5 into 4 into 3 into 2 into 1. Okay, now this could also be written as 5 into 4 factorial. Can you see this carefully? 5 is written as 5 as it is, and these are 4 terms. 4 into 3 into 2 into 1. What this can be written as? 4 into 3 into 2 into 1 could be written as 4 factorial. Clear? Now 4 factorial could be written as 4 into 3 into 2 into 1. So 4, you keep 4 as it is, and these 3 terms could be written as 3 factorial. Similarly, 3 factorial could be written as 3 into 2 factorial. 2 factorial could also be written as 2 into 1, which means 2 into 1 factorial. 1 factorial could be written as 1 or 1 into 0 factorial. Okay, so what is the pattern that you are seeing here? Can you find a pattern out here? See, 5, 4, 3, 2, 1. What is happening? 1 unit is getting reduced. Okay, now here 1 unit is getting reduced. Here 1 unit is getting reduced. Okay, so 5 factorial could be written as this term, 4 factorial could this term, 3 factorial could be written as this term, 2 factorial could be written as this term. Similarly, 1 factorial could be written as this term. Now take this, pick this. So 1 into 0 factorial is nothing but 1. Alright, now you want to find the 0 factorial, so simply make this 0 factorial as the subject of formula. So 1, you divide this 1 upon 1, so 1 upon 1 will get cancelled and this will give you 1. So hence we can prove that 0 factorial is equal to 1, so which is quite easily done. Okay, now if you don't believe my words, then take out your calculator and do it by yourself. You will definitely get 0 factorial. The value of 0 factorial has to be 1. So I hope you have already taken your calculator and verified this whether I am telling right or wrong. So the value of 0 factorial you will get as 1. Okay. Now you will be asking, sir, what about the factorials of negative numbers and fractions? Sir, is it possible to get so? My answer is, dear students, yes, this is possible as well as this is no. Now, I'll be giving you a big billion concept which is generally missed in schools and colleges. So it's a must jabardast concept. It's a very fantastic concept. So I hope you will enjoy this. Okay. So there is a task for you. Okay. So take your calculator and find the values of the following. Please involve in the task, pause the video, get the solutions of these and comment in the comment box. So what answers you are getting. Okay. So unless and until you involve yourself, you won't be understanding much. So please involve yourself. Take out your calculator, move your body, take out your calculator, solve this. So 0 factorial, 1 factorial, minus 1 factorial, half factorial, minus half factorial. Okay. I hope you have already calculated this. Now let's verify your results. What are the solutions that you might be getting here? So the value of 0 factorial you might be getting as 1. Value of 1 factorial you might be getting as 1. Minus 1 factorial you might be having a math error. Half factorial you might be having a math error. Minus half factorial you might be having a math error. Okay, so two possibilities you have. What? Actually it could be undefined as well. And the second possibility is that it might be out of range of your calculator. What does it mean, sir? See, actually undefined. So there are certain things in mathematics which could not be defined. Okay, so that we use the symbol just like infinity. Do you remember infinity symbol? So infinity symbol has got two meanings. This 8, inverted 8, that means 8 lying down, has two meanings. Inverted 8 has got two meanings. One which is undefined, and second, undefined means indeterminate, and second means infinity. Infinity means which is very big. The bigger than whatever you imagine. Okay, so if the number is out of the range of your calculator, so does it mean that if your calculator can't solve it, and which means is it unsolvable? No, sometimes it is not. Okay, so let's verify this. So I'm giving a very fantastic concept. 3 functions I'm introducing here. Please watch this with full patience and full clarity. Okay, so see 3 functions I am introducing: gamma function, pi function, lie function. Gamma function, pi function, lie function. Out of this you might be very well aware of this gamma function, but this pi function and this lie function might be new to you. Okay, so gamma function, see what is this small letter? So this is gamma. This is a Greek letter and small, just like we have capital A, small a, capital B, small b. Similarly we have small gamma, capital gamma. Okay, so what does it mean? So where have you used the symbol? We have used the symbol maybe in thermodynamics or in some other constants for having some notations or constants value. Okay, but this capital gamma has got a very special position in mathematics, and this capital gamma nothing means integrate. It means 0 to infinity e to the power of minus x, x to the power of n minus 1 dx. So this integral expression is being illustrated using the help of this gamma function. So how to read this? We will read this as gamma n. Okay, so gamma n is equal to integration 0 to infinity e to the power of minus x, x to the power of n minus 1 dx. Fine. Moving to pi function. So this is similarly, we have got a small pi and this is capital pi. Can you see the way of representing this pi? You can find this in your calculator as well. This is a constant. Okay, this pi is a constant. Okay, this which you'll get as 3.14 or something like 22/7. Okay, similarly kind of thing, but we are talking about a function, not a constant for this. So pi function, small pi of x is nothing but li of x plus capital O of x into e to the power of minus of root ln x upon 15. Okay, so this function is a big O notation, a big O function, which is actually the out of domain of your engineering part for the present course, but this plays a very important role in higher mathematics. Okay, so it has got a very wide application in different domains, but for the time being we won't be talking about this. Okay, so this is li function. Li x is equal to integration 0 to x dt upon ln t. So suppose if you want to find li of 2, what you have to do, simply you need to replace this x with 2. So li of 2 is equal to integration 0 to 2 dt upon ln t. Li of 7 will be equal to integration 0 to 7 dt upon ln t. Is that clear? Now, don't focus on this. Simply remember that there is some function called small pi function, and it is the meaning of this, and it has got the meaning of this. Okay, so you should have a far edge as compared to your batchmates, such that you will have a little more extra knowledge. But our focus of understanding is this one. So capital pi of n is equal to integration of 0 to infinity t to the power of n e to the power of minus t dt. Okay, so remember that this is important for us for solving the problem. This is important. This relation, that is gamma function, is important, and this capital phi function is important. Okay, and these are some extra knowledge that I have given you. Now you will be having some questions, how to use them for our benefit. The big question that arises in front of us is that how to actually use them for our benefit. What is the purpose of studying this gamma function, pi function and all? Unless and until it has got a very good use, why will I study this? Isn't it? So let's see. So remember this result. Remember this result. This result is actually the Brahmastra, or you say the solution for all problems. So n factorial could be written as capital pi of n is equal to gamma of n plus 1. For instance, say suppose if you want to find 3 factorial. So what you need to do? Replace this n with 3. Okay. So here you'll be getting 3 factorial is equal to pi of 3 is equal to gamma of 3 plus 1. Okay. So here n means kuch bhi means anything. So you can put anything here, anything. It may be an integer, it may be a fraction, anything, whatever you want to put, you can put. Okay, you will be saying, sir, I can't believe this. How can you say that? My calculator is not able to solve such problems. So, sir, can you give me some proof for that? Okay, this is the proof. See here, this is the proof for you that I have given. Recall this expression that just now I have given you. So n factorial is equal to pi of n is equal to gamma n plus 1 is equal to integration 0 to infinity t to the power of n e to the power of minus t dt. Okay, so this is the expression that you have. So remember only this expression. Whatever you need for solving the problems related to this is this expression. That is, what is the relation between factorial, pi function, gamma function and integral function. Okay, so this one liner formula can solve so many problems. Okay, now let's see, let's prove this by solving some of the problems. So one factorial, whatever the problem that I have given you and I told you to solve, so let's verify that. Suppose if you want to find the value of 1 factorial, so what you need to do, simply in place of n you have to substitute this 1. Okay, so see here, write this expression. You can take this integral expression. So 1 factorial could be written as integration 0 to infinity t to the power of 1 e to the power of minus t dt. See here, in place of n I have replaced this with 1. In place of n I have replaced this with 1. Simply you need to solve this integration. When you solve this integration, you will get the value of 1. So for the current lecture, at present time, I won't be discussing much about this integration, because this integration is not the domain of this particular lecture. When I'll be making the lecture for integration, I promise you that integration will become very, very easy. Whatever the type of integration that you'll get, you can solve that in fractions of time. Okay, so for the time being, don't focus on integration. Just imagine that you can solve this, and I'm very much sure that you can definitely solve the integration problems. Okay, my current purpose for giving you such an expression is that how to find the values of factorial. Okay, so focus on how to getting the values of factorial. So 1 factorial you have got as 1, quite easily done. Okay, coming to second problem, sir, you proved that 0 factorial is equal to 1, but with some other way. So can you give some proof with the help of some integration formulas? Yes, I have. See, 0 factorial could be written as this expression. So simply replace n with 0. If you put this, you'll get this expression. In solve this integration, you'll get the value of this 0 factorial as 1. Okay, so you go by that pair of method or pattern method, or you can go by this integral method. Both the methods will lead to the same result, that is 1. Moving to half factorial. So this is amazing, really amazing. Why? Because this half factorial could not be solved using calculator, but you can solve manually. See, we know this definition, that is n factorial is equal to pi of n is equal to integration 0 to infinity t to the power of n e to the power of minus t dt. Yes, we have remembered this expression. Now in place of n, simply substitute this half. When you substitute this half, you need to do a little substitution and solve this integration. For solving this integration, you need to make some substitutions. There are the other methods also you need to solve. You can solve this integration, but for the time being, I won't be focusing how I have solved this integration. You can just have a look on this, verify this, whether I have solved this right or wrong. Okay, whether I have applied the chain rule correctly or not. Okay, so that is your part. My part for this particular lecture is to make you understand how to find the values of the factorial, not the integrations. Integration part will be done later. Okay, so these are the different methods that I have applied. These are the steps that I have applied for solving the integration. These all substitutions and all. And finally, I have concluded that my final result for this integral is nothing but root pi by 2. So from here, what is the value that you got? That is half factorial is nothing but this root pi upon 2. Okay, moreover, you can remember this node. Okay, so this is a standard integral which is also called as a Gaussian integral. Integration 0 to infinity e to the power of minus m square dm is equal to root pi by 2. You'll find this expression, you'll have this expression, or you find its application in probability or various other forms of mathematics. Okay, you can go through. So again, sir, again brilliant thing you are doing. So you are able to find the value of minus half factorial. So my calculator is not able to solve this factorial, but you are solving this. That's amazing, really good. You can also solve this, fine. So in place of n, you can put minus half, get this value. Okay, solve this integration, and finally you'll get the value of minus half factorial as root pi. Clear? Now the question comes for this, the big question, minus half factorial. How get this? In place of n, you put here minus 1. When you substitute here, you'll get some integral expression like this. But here's the twist. This, see, every integration is not possible to solve. Okay, it's not possible to solve each and every type of integration. There are certain types of integration which are divergent in nature. Divergent means you won't be finding any solution. The solutions won't be converging. Always it will having a diverging nature. So that means your integration is not possible. You cannot solve this integration. When integration is not possible to solve, how will you get this value of factorial? That means it is undefined. Clear? So that's why, that is the reason I told you that the values of the factorials could be solved as well as could not be solved. So both the things are possible. So I gave you some examples in which the values of the factorials are possible, and I gave you one example in which the values of the factorial is not possible, which is undefined. I hope you got the idea. Let's see some other method also, whether I can get the value of negative minus 1 factorial with some other method or not. See, I gave you some pattern method, right? So n factorial could be written as n into n minus 1 factorial. Okay, so this is, you can write this 5 factorial, 4 factorial, 3 factorial, 2 factorial, 1 factorial, 0 factorial, and this can be written. What is the pattern that you are seeing? See here, 5, 4, 3, 2, 1. So 1 unit is getting reduced, isn't it? Here also 1 unit is getting reduced. 1 unit is getting reduced. So we had seen till here. Now if 1 unit is getting reduced, so if you subtract 1, so what you'll get next? So 1 minus 1 is 0. 1 minus 1 is 0. 0 minus 1 is minus 1. So finally you'll get this expression. Now use this expression, make this minus 1 factorial as the subject of formula, so which will throw this 0 in the denominator, and whenever 0 comes in the denominator, what does it happen? What does it mean? It means it is undefined. That means your denominator can never be 0. Whenever denominator becomes 0, that means it becomes undefined. Clear? Now further you can go. So 0, after this you will have minus 1. Here 0, you will have minus 1. So minus 1, minus 1, so you will have minus 2. So if minus 1 is factorial is undefined, that means rest of the terms, if you will go further down, every term will be undefined. I hope you got a very clear idea of the factorials. Now let's move into binomial coefficients. You know very well that binomial coefficient is nothing but given by this expression, that is NCR is equal to n factorial upon r factorial into n minus r factorial. Clear? Just for an illustration, let's see here 3C0 is equal to, here there is a mistake, it's a printing mistake, so sorry for that. So here you will be having 3 factorial, this will be 3 factorial, okay? Make sure this is 3 factorial. So 3C0 could be written as 3 factorial upon 0 factorial into 3 minus 0, which is 3 factorial. Okay, you'll get this. 4C1, which is 4 factorial upon 1 factorial into 4 minus 1, which is 3 factorial. So this is very simple, very easy, you can easily get it. Now this is the expression for this binomial theorem. This is the binomial expression or binomial expansion. So this is the theorem. The theorem says that if you have a polynomial like this, there's a sum of 2 terms and it has got some power n. So this could be expressed or expanded in this summation terms. Okay, so this is a short form of writing the summation terms. When you expand this, that is if you put n is equal to 0, n is equal to 1, n is equal to 2, n is equal to 3 and so on, you'll get this big expressions. Clear? This is the binomial theorem that we have learned. Okay, now there are certain things that you need to remember by heart. What are those? Product formulas. I hope you have already learned this in your childhood days, but if you have not learned, it's my sincere request, please learn this, because in an exam there is hardly any time left to do all these expansions and solve the problem. Okay, in competitive exams it's very challenging to make these expansions and then solve. If you remember these expansions by heart, it will be easier for you to solve and you'll be in the far better edge as compared to that of your competitors. Okay. Second formula list is factoring formulas. See, a square minus b square is equal to a plus b into a minus b. A cube minus b cube is equal to a minus b into a square plus ab plus b square, and so on and so forth. Okay, so this is the general expression that you have. Take the snapshot or write in your notebook, do whatever you want. But my request is please remember all these product formulas and remember this factoring formulas, and also remember that one-liner relation between the gamma function, pi function, integral function. Clear? And the factorial. I hope you enjoyed the lecture very well. You learned so many new things in today's lecture, and the upcoming lecture will be seeing the sequences and some more parts. Okay, and one more thing I would like to request you, if you have not subscribed, then please subscribe it. And moreover, if you motivate us to make some courses like this, that gives a motivation. Your likes and your share and your views gives us motivation actually. Okay, so please keep sharing. Tell your friends that Exademy has taken a lead of teaching the average and below average students, which are actually neglected in the recent times by most of the educators. Okay, so please stay with us and keep liking us, keep motivating us, keep pushing us. And if you want to connect with me personally, then you have all the contact details. Go ahead and enjoy your studies. See you. Bye bye.